in each of these problems, we have more than one logarithm in this one. This one here, the logarithm is not by itself. And so our goal overall is to get a single log by itself. In the first one here, what I'm going to do is push these two together to make one logarithm using the property the log of m minus the log of n equals the log of m over n. Okay, so I'm gonna push those together. Natural log of x plus 2 is in the numerator and 2 is in the denominator. Now that I have this single logarithm, the base that I may not notice here is its base e. That's that invisible base on natural log. Okay, so that e tunnels under and that natural log goes away. So I'm gonna have x plus 2 over 2 equals e to the power of -1. One of the strategies for solving and one of the strategies for simplifying, we don't want negative exponents. So if I had 5 to the power of -1, that's 1 over 5. I have e to the power of -1. Remember, e is a number, 2.71 something something. So I want to start by writing e to the -1 as 1 over e. And then another strategy, anytime your equation has fractions, a good idea is to multiply both sides by the denominators. So the denominators are 2 and e, so I'm going to multiply both sides by 2 and e. In this side, the 2's cancel, and I'm left with e times x plus 2. Here the e's cancel, and I'm left with 1 times 2. Okay, so 1 times 2 is 2. Now from here you have a couple of different ways that you could solve for x. And I'm going to go ahead and show both ways. It's a personal preference. When you realize that when you solve an equation you are undoing the order of operations, then you're more likely to go this route because the x is inside parentheses. So I'm going to undo what's inside parentheses last. So I'm going to focus on dividing both sides by e. Okay, so I've just rewritten the original because I'm going to solve it 2 different ways. So to get rid of times e, I'm going to divide both sides by e, and now that x plus 2 is freed up. Finally, to get rid of add 2, I'll subtract 2 from both sides, and I end up with a final answer of 2 over e minus 2. Some of you, however, taking a look at the exact same equation, as soon as you see a number in front of parentheses, you just immediately distribute, and that's fine. If I decided to do that, I'd have e times x plus e times 2. I'm still trying to get the x by itself, so terms with x in it on one side, terms without x on the other. So I'm going to get rid of the 2e by subtracting 2e from both sides. And then to get rid of multiply by e, I would divide both sides by e. And I end up with x equals 2 minus 2e over e. These answers look different, but they are the same. Remember, the e belongs to each one of those. So that's 2 over e minus 2e over e, and minus 2e over e, the e's cancel, so I get minus 2. So it's just a different strategy of solving. We're going to look at 2 more examples. This one is a little bit quicker. We need to get the single logarithm by itself. This one we had an issue because we had 2 logs, so I needed to push them together to get 1 log. But here I already have 1 log, but I've got to get it by itself. So that ln of x is getting multiplied by 3, and we're also adding 5. So the first thing I'm going to get rid of is the adding 5 by subtracting 5. Then I still have that 3 in front, so I'm going to get rid of that by dividing by 3. I end up with ln x equals 2/3. The e that's invisible here is tunneling under. So I'm going to end up with x equals e to the power of 2/3 when I change to exponential form, and I have my final answer. Okay, I'm going to do just one more here, and then you'll be able to look back at the saved notes as well. I've got to rewrite this as one logarithm, so I'm going to use the property ln of m plus ln of n equals ln of m times n. You push addition together with multiplication. All right, so I've got 2 multiplied by x minus 1. I'm going to go ahead and do that multiplication. So 2 times x is 2x, and 2 times -1 is -2. Now that I've pushed those together, I have a single logarithm. So I'm ready to turn this into exponential form. The e, that's invisible here, right? That's tunneling under. So I'm gonna have e to the power of -3. And on the left side, 2x minus 2. I can't have a negative exponent in my final answer. So the next thing I'm gonna do is rewrite this as 1 over e to the power of +3. Now I am tempted right now to use the strategy whenever I have a fraction in my equation, I multiply both sides by the denominator. But what's going to end up happening is if you do that, you're going to immediately undo it. So I'm going to leave that as is. To finish getting x by itself, all I have to do is get rid of this -2 and this times 2. So to get rid of the -2, I'm going to add 2. So I have 2x equals 1 over e cubed plus 2. Now at this point, this is just another, it's going to look really funny if I get rid of multiply by 2 by dividing by 2, because I'll have to underline all of this and put a divide by 2. So another way to get rid of multiply by 2 is to multiply by the reciprocal. So I'm going to multiply both sides by 1/2 rather than dividing by 2. That's going to prevent me from having a fraction over a fraction. Okay, so get rid of times 2. Instead of dividing by 2, I'm going to multiply by 1/2. So the x is by itself because the 2's cancel, and this 1/2 gets distributed through. When you multiply fractions, it's numerators times numerators, denominators times denominators. So 1/2 times 1 over e cubed, 1 times 1 is 1, and 2 times e cubed is 2e cubed. So I'm going to have 1 over 2e cubed, and then 1/2 times 2 is 2 over 2, which is 1. And we have our final answer. Now I haven't said this in these 3 examples, but please remember, anytime your original equation has a logarithm of x, you must check your answer. Now to quickly check this one, it's so ugly, I would do 1 divided by 2 times e to the 3rd, which again is 1 over 2 times 2.71 to the 3rd plus 1, I get an answer. If you take that number and plug it into x minus 1, you'll see that this number -1 is still a positive number, so we're good. It checks out, and it's our final answer.